The main difficulty in this question is that the structure of our function is quite different from the target form. If we can make the structures look a bit more similar, it will make our lives a lot easier. One way to do this is to expand out the expression a times x plus h squared plus k. Squaring a number is the same thing as multiplying that number by itself. So x plus h all squared is x plus h times x plus h. Now we can multiply out those brackets. X by x is x squared, x by h is hx, h by x is hx, and h by h is h squared. We can simplify this a bit. Hx plus hx is 2hx. Now let's multiply in this a. A by x squared is ax squared. A by 2hx is 2ahx. And a by h squared is ah squared. The expression we end up with has an x squared component, an x component, and a number component. This is the exact same structure as our original function. Matching coefficients will allow us to solve for a, h, and k. Matching the x squared coefficients, we get a is equal to 2. Matching the x coefficient gives 2ah is equal to minus 7. And matching the constant term gives us ah squared plus k is equal to minus 10. The first equation here gives us the value of a directly. It's 2. We can sub this value into our second equation to find the value of h. 2 times 2 is 4, so we get 4h is equal to minus 7. Dividing both sides by 4 gives us h is equal to minus 7 over 4. Now that we know the values of a and h, we can sub these into our third equation to find the value of k. Using our calculator, 2 times minus 7 over 4 all squared gives us 49 over 8. From here, we can isolate our k by subtracting 49 over 8 from both sides. Performing the calculation on the right-hand side gives us our answer. K is equal to minus 129 over 8. Remember, the target here was to write our function in the form a times x plus h squared plus k. We've now found the values of a, h, and k. So to get our final answer, all we have to do is write these in. Doing this gives the following. 2x squared minus 7x minus 10 is equal to 2 times x minus 7 over 4 all squared minus 129 over 8. The key to solving this question is the following insight. Squares are always greater than or equal to 0. This means that regardless of the value of x, x minus 7 over 4 all squared must be greater than or equal to 0. If we want to minimize our function, we'll want to make this as small as possible. In other words, we'll want to have it equal to 0. Since 0 squared is equal to 0, we'll achieve equality when the expression inside the brackets, x minus 7 over 4, is equal to 0. Adding 7 over 4 to both sides in this equation tells us that we'll have x is equal to 7 over 4. We want to find the minimum point of our function, not just the x value. To find the y value, we'll sub this 7 over 4 into our function. (7 over 4 minus 7 over 4 is 0, so we end up with 2 times 0 squared minus 129 over 8. This simplifies down to minus 129 over 8. This will be the y-coordinate of our minimum. So, putting everything together, the minimum point is 7 over 4, comma, minus 129 over 8. The key to solving this question is the following fact. The number of real roots of the quadratic function f of x is ax squared plus bx plus c depends on the discriminant b squared minus 4ac. If b squared minus 4ac is greater than 0, then f has 2 real roots. If b squared minus 4ac is equal to 0, then f will have 1 repeated real root. If b squared minus 4ac is less than 0, then f will have 0 real roots. In summary, if we look at whether the discriminant is positive, 0, or negative, this will tell us how many real roots the function has. At the beginning of the question, we were told that f of x is equal to 2x squared minus 7x minus 10. So in this quadratic, we have a equal to 2, b equal to minus 7, and c equal to minus 10. This means that the discriminant, b squared minus 4ac, will be minus 7 squared minus 4 times 2 times minus 10. This simplifies to 49 plus 80, which comes out as 129. Crucially, this number is greater than 0. Using our fact from earlier, this means that we can conclude that our function has 2 real roots. In this question, we must solve the equation f of x is equal to 0. In part A, we discovered that we could write f of x as 2 times x minus 7 over 4 all squared minus 129 over 8. So let's write this expression in for f of x. The resulting equation only involves a single x term. If we can isolate this x by removing everything else from the left-hand side, then we'll have solved our equation. A good principle here will be to start by removing the expressions furthest away from the x. Here, the first thing to remove is the minus 129 over 8. This represents subtraction, so to cancel it off, we'll need to add 129 over 8 to both sides. Next, we should remove the 2 in front of the brackets. This represents multiplication. To get rid of it, we should do the opposite, which is division. So the next step will be to divide both sides of our equation by 2. We can simplify on the right-hand side. 2 times 8 is 16. Next, we'll have to remove the square. The opposite of a square is a square root, so here we should square root both sides. We'll have to be careful here, since the positive and negative versions of a number both square to the same answer. To account for this, we'll need to put in a plus-minus sign on the right-hand side. Finally, we can remove the subtraction of 7 over 4 by adding 7 over 4 to both sides. This brings us to the final answer, that x is equal to 7 over 4 plus or minus the square root of 129 over 16. This is precisely the format we were asked to present our answer in.